Right. Awesome. Yeah, I think, right. So Connex is this bridge between these different layer twos on Ethereum. And of course, there are already other bridges also right now
Yeah.
that exist. And of course, one of the things that maybe are interesting in these bridges is, right, like for one, the cost to make a transfer between
Mhm.
the two networks and the time it takes for the
Mhm.
transactions to go through. So maybe you can explain a little bit, yeah, how Connex or like NXTP specifically like works on these two dimensions. Like how does it improve? How great does it do? And how does it do that?
Yeah, absolutely. So there's there's a bunch of different like kind of optionality that you have around these bridges, and like different bridges, different approaches take different trade-offs. So in general, cost and speed is like one of the pieces of optionality. So obviously you have things like rollup bridges; those are maximally trustless. Those are kind of like native to how the rollups work themselves. And like we all kind of know at this point that like with the rollup bridges, you like exiting those things is going to take like a week, and that's hugely problematic for user experience. We also see kind of the same thing with like existing like bridges that are baked into chain. So like the Polygon POS bridge takes 3 hours to get out of Polygon. Like half an hour to 45 minutes to get into Polygon, which is also just a huge pain. Um, that said, I would say that for the most part, with like a lot of the bridges that are live today and that have kind of gone to market recently, like you'll find that the cost maybe it's sort of like within the same region, but generally speaking, it'll be, I think generally speaking, NXTP is the cheapest. But like generally, it's also like kind of within the same range. And you'll also find that the latency of these bridges is within the same range, and that's I think because like we've all kind of focused on latency, and we've hit this like lower limit, which is basically how many blocks do you have to wait, like to confirm a transaction, because some of these chains are just like reorging a lot. So like Polygon, for instance, we wait like 80 blocks. I know Seller waits 80 blocks. I know like Hop waits 80 blocks, and the reason is just that like you know a few weeks ago we saw like a 65 block reorg on Polygon, and so like there's no way for us to really like go any lower than that because you have to wait that long for the economic security. Um, Now, there are a couple of other things that are trade offs that people have taken, and the three that I think that are really like important in the space, and we just wrote about this, are trustlessness, extensibility. So like how easy is it to take this bridge and like deploy it on a bunch of other chains, and then generalizability. So like what kind of functionality can you enable through the bridge? Like is it just simple transfers and contract calls, or can you do more complex things like NFTs? Like enabling generalized message passing. Um, and what we've seen is like just this is kind of more on the research side, but what we've seen is that there's a bit of a trilemma between these things. Like you can really only have two of them, because uh, the different approaches to trying to enable interoperability have to kind of like trade off one of these things against the other. So like you have like rollup bridges, which are very purpose built between a rollup and a chain. Those are maximally trustless. Those are maximally generalized, but you can't really like take that rollup bridge and then also apply it to like another rollup or another chain. Like you have to, it's kind of stuck between Ethereum L1 and a given rollup. And the same core concept applies, when you think of like, okay, well, what about MPC bridges, things like AnySwap, things like Thorchain, and you when you start looking into those, you realize, okay, well, actually, these things are great because you can deploy them anywhere. They're really, really generalized. But the trade-off is that now you're trusting some MPC nodes, and those MPC nodes have like 100% capacity and ability to rug the entire network. And those MPC nodes are by definition going to be less secure than like the Ethereum validator set, or like even like any other validator set of any other layer one. Um, so we as a project, I think that's kind of where like a lot of these different bridges are differentiating, is like which trade off they pick there, and like we as a project have kind of picked the trade off where we're like, okay, you know what, we really think trustlessness is very important, especially within the like layer two ecosystem. People want trustless solutions. We also think extensibility is important because it's so the space is so heterogeneous. We want to be able to bring Connext everywhere. We think it's like very critical that you do that. But we've traded off generalizability. We can't do like NFT transfers through Connext. You can't do like more kind of arbitrary data passing where the data is just like some event data, right? Like you can't do like, okay, prove that on XYZ chain the TVL of Uniswap is a certain amount of money, trustlessly between chains using Connext at the moment. And
So,
yeah, sorry, go ahead.
no. If you can finish off there,
Yeah, I was just going to say that at the moment that we've found that trade-off is okay for most users in most use cases.